Good morning. This video is intended to kind of piggyback off of the KML or KMZ conversion to shapefile video. And the purpose of this video is to show how to develop a fishnet across your site. The purpose of the fishnet is to develop transect lines or grids, whatever you need it for. But for our purposes, it's for survey design of following a transect line in the field. So in this case, I have an example project folder. What you're going to want to do is create a number of things in here. The first is field data. And so for gamma, we're going to be collecting gamma data in the field. So you'll create a gamma folder. You also have field forms. So when you receive your instrumentation and you scan the calibration documentation, you can put that in there. In your gamma folder is where we're going to put our daily gamma. So I just put, say, tomorrow, January 8th in there. You'll save your GSF files each day in there. You also save appropriate QC data in here as well for pre-survey, post-survey, and then in the field checks. So what we have is a shapefile of an area of interest. So in GIS, typically I'll have received data. I'll also have shapefile, and I'll have MXD, and sometimes I'll have geodata for doing geostatistics, and then whatever else you need, but this is a good way to organize it. I'm also going to open up our catalog here. So what you'll see, I also have another one called like analysis, where you can kind of do whatever you want in that folder. So now that we from the previous video, we had a KMZ file given to us that someone wants us to scan at. And so what we're left with is a NAD83 output for that shapefile for the area of interest. In this case, we are in New Mexico West. So I'm going to go to properties, and I'm going to make my layer New Mexico West as well. Here's the area. So the first step is kind of understanding what's the area that was given to us in say acres. That kind of helps us understand what we're expected to do. So I'm going to add a field called acres. Usually do double integer. You could also do short. So I'm going to go to calculate geometry and say acres. So this area is 15 acres, 15.77 acres. So what we want to do is create a fishnet that can then be loaded into our RadScout system. So another folder I like to have in this project folder is a RadScout. And the RadScout is something that you put on a USB drive. It has RadScout in capitals, just like this. It has to look like this. And any files you put on there, whether they're shape files or imagery or layer files, in the appropriate coordinate system, can then be transferred to the ERG's Mesa RadScout system very easily. So in the end, what we're going to do is generate these fishnets that we want to use in the field that we can then look at on our pad and follow when we get out there. So I'm just going to preemptively create a RadScout folder. Okay, so this is our area of interest. I'll just simplify this, make it a outline of what we're looking at, 15.7 acres. So the first step is go to fishnet. So I'm going to create a fishnet under data management. You can also access this under your Arc toolbox, but it's really easy to search for it. So creating a fishnet. Now, what's going to happen is under fishnet, you can either create a polyline or polygon. Now, polygons are really useful for creating grids across your site for zonal statistics or geospatial statistics. So if you want to take your grid and say, well, what's the average of the data within this grid? Then you can create a polygon. It's also good for setting up survey design for soil sampling or X-ray fluorescence sampling across the site. You also create label points as well. That would create individual points on a grid system across your site. For this purpose, we really want a polyline because we're going to be following these lines in the field. And we also want to be able to extract from horizontal and vertical. But what this is going to do is create a horizontal and vertical grid system across the region of interest. So, and at this time, I don't need label points. So I'm going to unclick that. So the first step is, what are we going to call this? So in our situation under GIS, this is an analysis. So in this case, I'm just it's an experimental analysis. So I'm just going to put Fishnet in there. I'm going to call this thing Fishnet raw whole site. And we know it's a NAD83. You can also do this in WS84, but then you're going to be working in decimal degrees for your height and width, and that's not as straightforward. So notice what's going to happen is a file is going to be generated called Fishnet raw whole site NAD83. So now I'm going to take the lower pond area NAD83 as our template extent. So from the top, left, right, and bottom, here are our coordinates. Here's the Fishnet origin. So notice it's going to take it from the X coordinate from the left, the Y coordinate from the bottom, the Y axis from your X coordinate as well, and then the Y coordinate is here. So this is what it's going to create. It's going to go ahead and create a grid over the farthest extents, vertical and horizontally, of your template extent. And now in this case, I want a 2 meter transect. And so, that's 6.5 to 6 feet, but so let's just say it's 3.28 feet for 1 meter, and we want 2 of those. So I'm just going to do 6.56 feet. So that's going to be our cell size width and cell size height. Now we're not going to put number of rows or columns because that's going to be dictated by the width and the height. Okay, so now we've got everything we wanted. We got our polygon. So now I'm just going to say OK. So there's our fishnet across the site. And if you zoom in, you'll notice that the distance is that is 2 meters. So in our case, when we're doing surveys, we may want to go horizontal, we may want to go vertical, we may just want a complete fishnet. Then you can decide in the field. So in this case, what I'm going to do is 3 things. I'm going to create a clipped fishnet, which would be full fishnet. And that's going to be the first thing. So now I'm going to clip the data. So I'm going to take this and I'm simply going to clip this. And then we'll call it fishnet clipped whole site NAD83. So now it's just in here. So that's, the user has that option to go. And that way, if you're working in difficult terrain and you're not in a flat area and you don't want to just go, north-south, you can kind of follow whatever direction you want. And it gives you an understanding of what that level of coverage is based on the 2 meters. So I always like to have that. And in some cases, you may want the whole thing. And that allows you to go outside of your bounds in case you haven't met the lateral extent requirements. And that's usually a good idea to have. And that way you don't have, to go rogue outside of that area. But in reality, we typically like to go in one direction, north, south, east, west. So what I'm going to do now is just basically extract the north, south lines. And so I'm just going to create a line up here. across that gets the vertical lines right here. So now you'll notice we just extracted the vertical lines. So now I'm going to go back to my analysis fishnet and call it fishnet vertical. Now it's still raw vertical. And then get rid of those. And then what I'm going to do also is open the attribute table. I'm going to switch my selection. So now I have the horizontals. I'm going to export the horizontals in the same way. Okay, so now what we're working with is horizontals and verticals across the whole region of interest, not just the site. And for the purposes of this video, I'm just going to do everything I'd want to do and have available just in case. So I'm going to take the verticals first and clip them to the lower pond area. And we have fishnet vertical clipped whole site. So now they're just going in here. So that way, if you have really strict requirements to stay within a boundary, you can then load these into your rad scout. They're going to be just within the site boundary. Now, in the same situation, if you hit an area of interest and you want to keep going, then go ahead and it gives you the option to continue outside of those bounds. Then I'm going to do the same thing with the horizontal. So we're going to go back to analysis, fishnet, horizontal, change it to clipped. Oops. We want to clip to the lower pond area. And we'll go here and change it. Now, one thing I forgot to mention, which we're going to do anyways, but in some cases you may want 10 meter or 20 meter or 5 meter. And so it's a really good idea to put the meter of your fishnet. In this case, I'm only concerned about 2 meter for the purposes of this. But in the future, the first one for fishnet raw should say fishnet _ 2M for 2 meter. That way, if you have a multitude of transect requirements or decision making, so maybe you start out at 4, look at the data, then go to 2, you would have that information. So in this case, we didn't need it because we're doing just 2 meter. So now we're left with the fishnets inside for horizontal, for vertical. We've got the entire horizontal vertical if we want it. We've got the entire fishnet 2 meter. Within the site, and then the entire fishnet outside of the site. So the last step is, these are all in NAD 83 for the purposes of fishnet development. But in the field, the person using this data is going to want to load it on their Rad Scout Mesa. Now, theoretically, you can put it in NAD 83, but then you'd have to change all the settings on the Mesa. It's usually good. We want to work in WGS 84 for this client. So here I'm going to do project. So the first step is, let's create our lower pond area, NAD 83. We're going to put it into WGS 84. We're then going to put it into our Rad Scout folder, which is really going to be basically the site boundary, lower pond area boundary, WGS84, save that, say okay. Okay. And I'm going to save this MXD into this example project directory under GIS, under MXD, and we'll call it Fishnet Development. In that 83. Okay. So that person is going to need to know where to get to. So that's the first one, is the lower pond area. Notice it's in the Rad Scout folder. I'm sorry, it's in the example project folder under Rad Scout. You'll notice we've got the first one there. So then the fishnets we want are all of these. So I'm going to call the first one we'll call this fishnet 2 meter WS84. So fishnet, we'll just keep it consistent, raw. We'll call it expanded site so they're not confused. Expanded site. So that's expanded outside of the site. And again, we're going to do output to WS84. And this is weird because of this video. Okay, so there's our whole site. Okay, the next one is clipped to the site, 2 meter full grid. So again, we're going to project that one to WGS84. And just make the name so that you know kind of what you're doing. Fishnet. This is really, we should probably call it full grid. Well, I think Rob will explain that. Expanded site. This is clipped to site. Okay, so there it is. And then again, what we want to probably do in the field is have a vertical and a horizontal. I think what we've done is enough for if they want to go out, they have this one. So we don't need to do horizontal, vertical. We're just going to do 2 more. We're going to do the clip to site vertical. So fishnet, this one will be called vertical, 2 meter transects clipped to site. Because that fishnet indicates that that's a grid system. WGS84. So this is probably the one they're going to use unless they want to go horizontal out there. And then finally, so this is horizontal. Okay. So now I'm just going to kind of go over really quickly. Here's all of our NAT83 information. Again, we're projecting in NAT83. So now I'm going to go to the Rad Scout folder. We've got a polygon, and we've got 4 polylines. This is what's going to go into the Rad Scout route. Mesa, it gives the user options for what they want to do based on site conditions like terrain. So for example, they're going to go out to the site and they can use this to navigate to the site. They can understand the bounds of the site. They can then, if they decide the north-south is the best, you can do north-south transects and just load that, and then you'll be able to follow that and collect your data on those lines. Similarly, if horizontal. And that's why it's good to check your data. In this case, looks like I did the wrong one. And so if that happens, what I'm going to do is go back to Rad Scout, refresh this, the horizontal one. What I like to do, so I don't have to okay, so I'm going to go back here. I'm going to go to vertical clipped. This is, that's what I did last time. So I'm going to do horizontal clipped. I'm going to project it. And that's why I saved this, because now I just remove the old, because this will be hopefully right this time. WGS84. Okay. And now I can go in here and remove the old one. So that's what they're going to have in the field. Again, going over it one last time. You've got your site, you've got your vertical transects, you've got your horizontal transects, you've got, here's your site, you've got your fishnet all the way for a long time. I expanded outside of the 15.7 acres and then also clipped to the site, allowing for robust choices when you're out there doing your survey. So now the next step would be simply putting this Rad Scout folder onto a USB, inserting it into the ERG Mesa Rad Scout, clicking Rad Sync, and now when you open up your navigation software, you can load that as a background file and collect data on those lines. So thank you very much.